stuff, and so I can't quite actually get a longer cord. That's just the way things are sometimes, and I guess the fact that this is knotted doesn't help. You know, maybe I could fix that. That would probably be a good start as well. Let's see if that helps. It's a little better. That actually is a little bit better. So anyway, welcome to Handmade Hero. Today we are, as the Romans used to say, having our lunch and eating it too, where we are going to try and get our debug system into a state where it both works for sort of like everything dumps into a log on the game side of things. So there's no actual interruption of the game running, no matter what kind of debug stuff you're doing. Or on the debug side, it's just all sort of pulled up and collated and put into a format that's easy to sort of like view and do all these other sorts of things. It's sort of like the all-you-can-eat lunch buffet of debug information. And like any lunch buffet, you end up in a situation where, you know, sometimes the sneeze shield doesn't go down all the way, and you know, some of those little troughs get contaminated, and everyone in the restaurant gets sick. Other times it's great, and they have the chicken tikka masala or whatever that you really like, and you can just have as much of it as you want. And so we don't really know which kind of a lunch buffet our debug system's going to be yet. We're hoping that it's going to be the kind with the tikka masala and not the one where somebody sneezed into the saag paneer. It's pretty hard to tell in saag paneer whether or not someone has in fact sneezed into it, because it kind of has that sort of green plus yellow look to it already. And so even if they were really, really sick and sort of had a fair bit of bacteria in their mucus, you wouldn't necessarily be able to, you know, kind of see it. So I guess what I would say is that's where we're at, and that's kind of a gross thought now that I'm thinking of it. I kind of wish I hadn't brought that up, but, you know, whatever. What can you do? So we're going to jump back into it. Pretty much same thing we were doing yesterday, just trying to like wrap up some of the code there. This, of course, is day 218. So if you want to follow along at home, you want to unpack day 217 source code into a directory, and that is what I'm starting with today. So here we go with the handmade heroing. So I'm just going to go ahead and build here, and if I remember correctly, we turned off the debug system just so people wouldn't have any trouble running it and so on. So we don't have it on at the moment, and everything's, wow, look at that guy zip around there. Okay, so, go back from that. But what we need to do if we actually want the debug system to run is we need to change our pound define to turn debugging back on. And so now we're back to where we were yesterday, which is we were kind of in the middle of making changes. And so let's go right back into it. Like I always say, if you don't like what you have for lunch, the best thing to do is to just eat it as quickly as you can. There will always be a better lunch tomorrow. So let's take a look and see where we're at. Here we are with our GWID stuff. We just did this. Here we are with our GWID stuff. We just did this yesterday. What we wanted to do was sort of make it so that no matter where we were in the debug recording process, any event that got recorded would basically have a GWID associated with it, so that we knew that a particular location in the file could be uniquely identified, so that all of the events that came from that location could sort of be grouped together and looked at as a whole. Now, of course, what we didn't do is we didn't actually change. Here we are with our GWID stuff. We just did this yesterday. What we wanted to do was sort of make it so that no matter where we were in the debug recording process, any event that got recorded would basically have a GWID associated with it, so that we knew that a particular location in the file could be uniquely identified, so that all of the events that came from that location could sort of be grouped together and looked at as a whole. Now, of course, what we didn't do is we didn't actually change up in here the definition of a debug event. So that's kind of a thing. And you know what? We've actually got a to-do in here, which we can get rid of because we got rid of the line number, and now we've just got GWID. We still have block name, which is a different thing, and I don't know if we want to keep block name or get rid of block name. We may be able to get rid of block name as well in the future. Let's just say to-do Casey, should we remove block name altogether? And I don't know whether we should or not, but you know, we'll find out. So let's see here. We also, I think, maybe missed a backslash at some point. We might have. No, I guess we've got it in there. So we just need a semicolon. That's about it. And then I think we're good. Now, what we also have to do here, because this is one of those things that happens, especially in a situation where it's kind of like, you know, we're making a fair bit of changes. It's like I always say, when you're trying to serve lunch, if, you know, all the place settings are sort of shifted around, then everyone sits down and they don't know where to eat, right? And so one of the things that you need to do as a programmer is when you're serving lunch, if you want to do something where you shift the place settings, you got to go through and tell all the people who are coming to the lunch party that they need to kind of move over from their normal positions. And that's exactly what we have to do now, right? Because these people, when we do like these initializations and all that stuff, we need to sort of go in here and correct the stuff that was expecting there to be file name, block name, etc. And now there's going to be that GUID thing. So in here, we pass in the file name and all that sort of stuff, line number. So what we want to do here is actually just be passing in the GUID instead. And we're going to have to, you know, make that work, right? Here we go. And of course, the way we get the GUID is we do this thing. So we can, just anywhere that we were doing that before, we should be able to make that work. I'm wondering as well if I could do something like this, sort of. I'm wondering if this will work. I'm wondering if something like that would be plausible, so that basically this would just, you know, would just look like that. And I don't really know, but I'm going to try it anyway. So okay, if we do this, then anytime we call debug initialize value, obviously it's going to be incorrect. Oops, there we go. It's going to be incorrect now, so we're going to have to make sure that works. And you can see there we're getting those errors. So debug initialize value. Let's go ahead and find that. I guess it's only in these two places, so that's actually pretty straightforward. And you can see here we've got file line path sort of stuff getting passed. So what we want to do is get rid of these here, file and line. We want to keep path because that's the name, but now in place where the GUID was going to be, we want to do that unique file counter string. Like so, and hopefully that'll work. I don't know if it will work. Like I said, with macros, it's always kind of a little bit of an adventure because I never remember exactly how the macro processor works, other than the fact that I always remember that it's a giant steaming pile of lunch, as I always like to call it. So here we are in add variable to group. So now we've kind of that suggests to me that we've sort of corrected the errors that we had from the GUID situation. And we're back to sort of dealing now with the actual stuff, the actual structural stuff of the debug system that now has to change because of the stuff that we did yesterday in deciding how it was going to work. And so let's go ahead and push forward. Oh, and that reminds me of something that I wanted to do as well, which I thought of this in the shower this morning. I was sort of, you know, as I often do, my brain just randomly thinks about something that I had been working on program-wise or whatever. And, you know, it's kind of like one of those things when you're at the lunch table and you're just eating your lunch and your brain just kind of drifts off to think about memory allocation. What I remembered is that when we were doing this code, we actually didn't quite do it right. We don't know this yet because we haven't actually gotten to the part where we're relying on it. But when we do this arena has room for thing, this code is actually not really correct. The reason it's not correct is because we are never actually planning to free any memory. We're just planning to recycle it. So the arena is never going to have more room, no matter how many times we free a frame. So really, push size with deallocation was the wrong way to write this. What we actually wanted to do was have our allocator thing, which allocates event stuff. We wanted just that to like look and see if there is an old one to use, and if there isn't, allocate memory, or rather free frames until it can. So this was actually wrong. This is actually totally wrong and needs to be different. That's just kind of a lunch sort of thing that we need to do. It's like less of a dinner. It's not really a dinner or breakfast thing. It's more of a lunch thing. Kind of like, you know how sandwiches, like no one eats a sandwich for breakfast or for dinner. They eat it for lunch. It's that kind of a thing. All right, so moving on. Let's get back to business here, because that's the memory stuff we can do later once everything is structurally back and repaired. So what I want to do here, again, is I want to get this working so that we're keeping everything in the element hash, so that anything that comes in, anytime we see a particular location coming through, we want to sort of have the collator put it into basically a location based on where it came from in the code. So that's what that GUID thing is for. We're just going to use that GUID to just do, we're doing a basic string hash here, where we're just going to take whatever we see there and put it in. Now, when I say string hash, I don't really mean it, because one of the nice things about this, just to be really clear on what I'm doing here, you can kind of see what I did for the GUIDs, right? In this unique file counterstring thing, what it does is it creates a concatenated string. And that concatenated string is created at compile time. So when it gets created, it's going to be put into the string table of the executable. And because it is a unique string, that means that every single one of those will get a unique pointer in our program, which means that I don't actually have to hash the string, which would be relatively slow, because I'd have to go through all of the elements of the string and add them together, or with some kind of a hash function, and put a to-do better hash function in there or whatever. But because I happen to be doing it this way, where I know that they'll all be put into a string table and have unique pointers, it means that really what I can use for the hash table is just a pointer to the string. And I know that no two strings that were generated this way will ever collapse into the same pointer, because they each are a different string. So that's kind of handy. So really what I want to do is, when we do collate debug record, we go through these events, and what we can do is every time we see an event, we can use the GUID from the event to create the element hash. So we can basically say, like, all right, there's going to be an element that corresponds to this, and we want to do a get element from event kind of a thing. What we would do is pass the event, and it would use the GUID in the event to determine which one it was and return us the proper debug element, right? So that's really straightforward, right? It just looks like this. We have our debug state, which one it was, and return us the proper debug element, right? So that's really straightforward, right? It just looks like this. We have our debug state here. Oops. And we've got our debug event, like so. And all we want to do now is we want to just grab out of this element hash the correct element for our event. Now our event has that GUID, right? So we have the, we almost could just use sort of the UIT32ness of it all, right? In fact, I guess we should do memory index, right? And this is a little bit dainty. It's a little bit sort of weird. So if we take this thing, which is a pointer, and we create it to a memory index, the problem is we don't really know how big that is, right? If we're compiling in 32-bit mode, which we may want to do someday, we're not compiling in 32-bit mode right now, but there's no real reason why we couldn't. It could be a 32-bit value, because the pointers would be 32-bit. If it's a 64-bit compile, then it's going to be a 64-bit value. And so we don't really know what we would do with our hash function here, because we'd want to mix the top into it if it was 64 potentially. But what I'm going to do instead is I'm just going to treat it as a 32-bit value, because what I want to do is say, all right, chances are the string table is going to all be in one relatively confined location, so it's probably the case that the top part of the string pointers are not going to be relevant, right? That's just my assumption. Now, I don't actually know if that's true. That might be totally wrong, but that's just what I'm assuming. So hopefully that's the case. So what I want to do is just use the 32 bits, but I also know that in general, it's probably going to be true that the pointers are not going to be unaligned. Like, they're probably not going to give me pointers that are on like byte boundaries. I'm just guessing that's true. I don't know it's true, but I'm guessing. So what I want to do instead is I want to do something where I cast this down to either 64 or 32, don't care. I want to shift out some of those low bits because I don't think they're going to be relevant. and then I'll make that be my hash value, right? So here's my hash value, like so. Okay. So then what I do is I say, all right, the hash value, and I'm going to go ahead and mod it by whatever the array count is of the thing we're going into. And I would like, by the way, to verify, I'm just going to put it here, to do Casey verify this turns into an and, not a mod. So we may do that as well. So this is the index, right, into the hash table. So we get the hash value back. We find out where we would put this thing. And after that, we then say, all right, that means that the debug element that we're supposed to be looking at here, or rather the chain, I guess I should say, is going to be the element hash with that index. So now all we're doing is we're just going to look through to see if we can find it. And so for any given one here, if the chain GUID equals the GUID that we're looking for, and again, you'll notice here, I'm not comparing the strings. And the reason I'm not comparing the strings is exactly the same reason I just said. We know that the pointers to the strings are unique, so it would just be a complete waste of my time to actually compare them with a string comparison of some kind. Right? It's like, you don't eat lunch if you're already full, right? That's like first rule of programming. You don't eat lunch if you're already full. And so, you know, in this case, we're already full by just checking the GUIDs. There's no sense in eating some extremely elaborate lunch at that point when all you're going to do is puke it up afterwards. So we go through the chain here. We see if we find one. If we have found one, then we can just immediately know that we found our answer, right? And here's our debug element. We know we found our answer, so everyone's happy, and we can return a result here. We could return out from the middle of this. I don't tend to love sort of returns out of the middle there. I just don't. I like sort of my functions to have a clean ending point that I know they always go to. So unless I really feel like I need to, I tend not to do that. So here I'm just going to go ahead and say that, okay, we grab that result, and we go. Here we'll check to see if we did not get a result. We will then go ahead and put one in, right? So if we did not get lunch, and so extremely elaborate lunch at that point, when all you're going to do is puke it up afterwards. So we go through the chain here. We see if we find one. If we have found one, then we can just immediately know that we found our answer, right? And here's our debug element. We know we found our answer, so everyone's happy, and we can return a result here. We could return out from the middle of this. I don't tend to love sort of returns out of the middle there. I just don't. I like sort of my functions to have a result. We will then go ahead and put one in, right? So if we did not get a result, oops, then we know we need to do a allocation to actually allocate a new debug element, which I will go ahead and do. So we'll just do push struct, debug state, debug arena, and now you'll notice that I'm not using our other, our allocation, our special one that's supposed to do the freeing thing, because I realized, like I said, that was actually stupid. So we don't need to worry about that for the immediate moment. But anyway, so I'm going to do a push struct. I push struct the debug element here. So now I have a new one. And then I just need to put it into the hash table. It's really pretty basic, right? So that's the location of it. Whatever the next in hash is of this guy will point to whatever was there before, which might be 0, might not be, we don't know. And then we'll chain ourselves in. Now, once we've created a new one, obviously we also probably want to initialize it at that point. So whatever the debug element is here, that new one in. Now, once we've created a new one, obviously we also probably want to initialize it at that point. So whatever the debug element is here that we're talking about, you can see it's kind of got some stuff. So we set up the next in hash, and that's good. But we probably also want to set up like oldest event and most recent event to point to nothing, right? And then we also need, like I said in here, we kind of need these to have a GUID as well. So we have to have in here essentially it's just a char star, right? That's the GUID. And so in here we'll say, well, whatever the GUID is whatever came in on that event. Like so. I'm also going to put an assertion in here just to remind myself that everything needs to have a GUID. So that way, if we kind of had some stuff lying around that never sets that GUID, when it does thing, we'll go and fix it. Because I want everything to have that. Okay. Because remember, since we never touched the string here, so again, this is not just a redundant assertion. It's not asserting something that's just going to crash a little bit later. This assertion is important because if I didn't assert that, a GUID of 0 would just work. This whole function would just go ahead and go, right? So I really wanted to make sure that we don't ever have a GUID of 0 because I want everything to have a unique GUID. So I just want to make sure that it's never going to do that. And that's yeah. In fact, I could just say that. So that's all that is, and here you can see me getting that element now. So now I can compile that, and hopefully everything is fine. In fact, I guess I didn't really look to see where we were at in the compile structure there. Where is that stuff? So did that all just compile first time? Wow, that is like that's like getting lunch delivered. There is what that is. That's pretty great. All right. Anyway, well, we don't know that it worked. So it's kind of like getting lunch delivered, but you don't know if you like it. You know, it's kind of like getting lunch from a restaurant you've never been to before. And so it's kind of cool that it got delivered because you don't have to do any work, but it may be something really awful, right? Like it could be like a Salisbury steak or one of those things that's kind of in that like mucilaginous kind of gelatinous goo. And, you know, do you really want that even if it is delivered? You know, maybe if you're really hungry, you know, you'll eat that. You know, beggars can't be choosers, that's what I say. But at the end of the day, if you are someone who maybe you can cook or can afford to get a better lunch than the Salisbury steak, then maybe you would, right? Maybe you would elect to make that decision. So, all right, we have a little bit more work. Maybe you would elect to make that decision. So, all right, we have a little bit more work to do here, like I said, to kind of like clean up what's going on here. This stuff here with creating variable groups, that again is not really relevant at the moment. I'm wondering if maybe we just if-zero it out for the time being even, because really this stuff is not relevant at the immediate moment. What's actually going to happen now, right, is in here, right, where we do this hash event add variable to group, this stuff, right? Add variable to group, what we're at here, even, because if-zero it out for the time being even. Because really this stuff is not relevant at the immediate moment. What's actually going to happen now, right, is in here, right, where we do this hash event add variable to group, this stuff, right? Add variable to group, what we're actually going to do is take whatever this event thing that came in, and we're actually just going to put it onto where its hashes like event stream, right? So whatever the element was that it corresponded with, which we've already found, right? Because we already did hash. Wondering if maybe what's going on here. That again is not really relevant at the moment. I'm wondering if maybe we just if-zero it out for the time being even, because really this stuff is not relevant at the immediate moment. What's actually going to happen now, right, is in here, right, where we do this hash event add variable to group, this stuff, right? Add variable to group, what we're actually going to do is take whatever this event thing that came in, and we're actually just going to put it onto where its hashes like event stream, right? So whatever the element was that it corresponded with, which we've already found, right? Because we already did the work right here to get it, right? So all we're really going to do is say when we get one of these, we're going to go ahead and dump that into whatever the element is that's currently open, right? And that's all that is. So yeah, I mean, this again starting to sort of coalesce a little bit here. There's still just a lot of work to do, but Excuse me. It's all good. So we have a debug stored event, and this is really the only thing. This is kind of the thing I was talking about before, where I was like, I kind of was just being dumb when we did that stuff to make everybody go through the allocation call. That was just stupid. Not very bright. So what we want to do here is, okay, we need a new stored event. This is the only thing that's actually going to get recycled, because everything else is a standing structure that persists. But stored events just kind of like pile up until we run out of space for storing stored events, and then we free old stored events. So what we really wanted to do is we wanted to make that be the way this thing worked. So what we really want to do is do like an allocate stored event, right? Or get, or like store, just maybe the store event, right? And so what we do when we do store event, we pass the debug state, that will take care of that allocation thing for us. And then we'll say, okay, whatever the stored event is, we know that we've got some stuff to initialize here, right? We've got the next, we've got the frame index, and we've got the event. Now the event is the easy part, because the event is obviously just coming directly in. So we can like quite literally just copy whatever the data is there and be done with it, right? That's super simple. But the other stuff is a little bit more complicated. For the frame index, we have to know what frame we're on right now. And so fortunately, we know that if we're in here, we do know that piece of information, right? So we know that whatever frame we're collating, that's got an index. So we will just go ahead and stuff that in there, and that's pretty great. You know, easy peasy lemon squeezy, like they say when you're about to, I don't know if you guys take tea at lunch, but if you're the kind of people who do tea at lunch, it's just customary for everyone to kind of go around the table and take a lemon slice and go easy peasy lemon squeezy, and then you squeeze it into the tea. Obviously, you don't do that if you drink tea with milk, because it'll curdle. So, you know, I mean, why would you do that? That's just dumb. You know, it's like, haven't you ever drank tea before? I don't even know what to say. But point being, the only thing we have left then is the next. And the next is part of this sort of chaining thing here that we're doing, where we want the debug elements to just sort of be able to stack up events inside them. And so to do that, what we would say is, all right, the next element is always going to be 0, because we're chaining this on to the end, which means that it's really just the element itself's pointers that have to get updated. The oldest event and the most recent event, would become this stored event in the case where they, where they are 0, right? So if we don't have anything on this debug element yet, which means that, you know, both of these things are 0, then we're just going to go ahead and put the stored event as the only thing in the list, right? It's both the oldest and the most recent, so it's the entirety of the list, right? But if there was one, then whatever that most recent one is, its next pointer is now going to point to us, and then the most recent frame is going to be the store event, right? And I always like this kind of weird, like, cheaty way of doing this, which is that it's kind of fun, right? I don't know, you know, if you guys are down with that. Maybe you are, maybe you aren't. It's not really my problem at the end of the day. It's like, everyone should eat lunch where they want. And everyone should have the lunch that they want, you know? Don't let other people tell you how to eat your lunch, because that's that's lunch despotism, and it's not okay. So let's push forwards a little bit here. I don't really know if we care about this stuff just quite yet. I'm going to take a look at some of these other things first. So, all right, I'm pretty sure we don't really want the region stuff to be happening at the moment. So, all right, I'm pretty sure we don't really want the region stuff to be happening at the moment. So I'm going to take a quick sort of gander at this and say that we don't want those. For the time being. I'm also going to say that we don't want that, and that's how that goes sometimes. Excuse me. For mark debug value, in this case, again with the add variable to group, in this case, I think we still want this to be essentially doing what this is doing here. I think we still want this to be essentially doing what this is doing here. And so what I want to do probably is make it so that there's the concept, the store event thing, we could probably do as sort of a as sort of a utility function. So I could maybe even do it just like this, right? So I want to do a store event, and that'll like do this whole thing for me, and that way I can call it in more than one place if I want to, and go from there. Okay, so here we go. Internal void. Here's my store event. Oh, and I guess that's not so void after all. So there's my store event. There's debug state. There's the debug element. There's the debug event. And now, all I have to do is just make this thing. Well, I guess I really don't have to do much now that I think about it. I don't know why add. Right? It's like, you don't eat lunch if you're already full, right? That's like first rule of programming. You don't eat lunch if you're already full. And so, you know, in this case, we're already full by just checking the GUIDs. There's no sense in eating some extremely elaborate lunch at that point when all you're gonna do is puke it up afterwards. So we go through the chain here. We see if we find one. If we have found one, then we can just immediately know that we found our answer, right? And here's our debug element. We know we found our answer, so everyone's happy, and we can return a result here. We could return out from the middle of this. I don't tend to love sort of returns out of the middle there. I just don't. I like sort of my functions to have a clean ending point that I know they always go to. So unless I really feel like I need to, I tend not to do that. So here I'm just going to go ahead and say that, okay, we grab that result, and we go. Here we'll check to see if we did not get a result. We will then go ahead and put one in, right? So if we did not get a result, oops, then we know we need to do a allocation to actually allocate a new debug element, which I will go ahead and do. So we'll just do push struct, debug state, debug arena, and now you'll notice that I'm not using our other, our allocation, our special one that's supposed to do the freeing thing, because I realized, like I said, that was actually stupid. So we don't need to worry about that for the immediate moment. But anyway, so I'm going to do a push struct. I push struct the debug element here. So now I have a new one. And then I just need to put it into the hash table. It's really pretty basic, right? So that's the location of it. Whatever the next in hash is of this guy will point to whatever was there before, which might be 0, might not be, we don't know. And then we'll chain ourselves in. Now, once we've created a new one, obviously we also probably want to initialize it at that point. So whatever the debug element is here that we're talking about, you can see it's kind of got some stuff. So we set up the next in hash, and that's good, but we probably also want... I think we still... Yet, I'm going to take a look at some of these other things first. So, alright, I'm pretty sure we don't really want the region stuff to be happening at the moment, so I'm going to take a quick sort of gander at this and say that we don't want those for the time being. I'm also going to say that we don't want that, and that's how that goes sometimes. Excuse me. For mark debug value, in this case, again with the add variable to group, in this case I think we still want this to be essentially doing what this is doing here. And so what I want to do probably is make it so that there's the concept, the store event thing, we could probably do as sort of a as sort of a utility function. So I could maybe even do it just like this, right? So I want to do a store event, and that'll like do. And so debug value in this case, again with being, I'm also going to say that we don't want that. And that's how that goes sometimes. Excuse me. For mark debug value, in this case, again with the add variable to group, in this case I think we still want this to be essentially doing what this is doing here. And so what I want to do probably is make it so that there's the concept, the store event thing, we could probably do as sort of a as sort of a utility function. So I could maybe even do it just like this, right? So I want to do a store event, and that'll like do this whole thing for me, and that way I can call it in more than one place if I want to, and go from there. Okay, so here we go. Internal void. Here's my store event. Oh, and I guess that's not so void after all. So there's my store event. There's debug state. There's the debug element. There's the debug event. And now, all I have to do is just make this thing, well, I guess I really don't have to do much, now that I think about it. I don't know why add variable to group is still there. I think that's pretty much all I would need. I just now need a way to get the actual stored event, right? And this should be stored event, by the way. Right? And so what I need to do here is just have a way of getting this, and that's the thing that we don't know at the moment, so that's fine. But oops. Now what we can do, and what are you complaining about? Most usage frame is not a member of debug element. Is that really true? Are you just joshing? Are you just messing with me, man? Are you messing with me? Where is my debug element? Oldest event. Oh, most recent frame? It's not most recent frame. It's most recent event. Duh. There we go. So let's see here. Okay, so we've got add region. This is still doing that that region stuff, so we're gonna take that out for the moment. There we go. Oops, got a little bit zealous with my hotkeys there. Ended up creating two versions of the compile. Always good to see them in mirrored. So let's see here. Create variable group. Again, this is not particularly relevant, so I think at this point I don't actually care. Link children and debug block. What are you complaining about? Most usage frame is not a member of debug element. Is that really true? Are you just joshing? Are you just messing with me, man? Are you messing with me? Where is my debug element? Oldest event. Oh, most recent frame? It's not most recent frame. It's most recent event. Duh. There we go. So let's see here. Okay, so we've got add region. This is still doing that region. Let's see here. Okay, so we've got add region. There we go. So let's see here. Okay, so we've got add region. This is still doing that that region stuff, so we're gonna take that out for the moment. There we go. Oops, got a little bit zealous with my hotkeys there. Ended up creating two versions of zealous with my hotkeys there. Ended up creating. Take that out for the moment. There we go. Oops, got a little bit zealous with my hotkeys there. Ended up creating two versions of the compile. Always good to see them in mirrored. So let's see here. Create variable group. Again, this is not particularly relevant, so I think at this point I don't actually care. Link children and debug block group. I don't care about this at all at the moment. Matching block, events match, deallocate open debug block, that's all fine. And then here is our store event. Yeah, so that takes care of that. And here up at the, where are you? Yes, mark debug value, that also stores the event. Now I suspect that we probably will be able to clean up a bunch of this code as well after things start to collapse down a little bit. At least that's my assumption. But we'll leave that for later. Okay, so we don't care about the values group anymore. We don't care about the add tree anymore. And we don't care about that. Okay, so we're back to just now. We're almost to the point where we can start to pull things back together again. Like I said, this push size with deallocation thing, that was just a very bad idea. That was my bad. I apologize. I made a faux pas there. It was a pas that was made of faux. Kind of like, you know, the programming equivalent of when you you go to lunch and you sit at the wrong seat and everyone's embarrassed and it's just kind of this this horrible thing, and you just kind of run screaming and crying from the restaurant, and it scars you for life. So anyway, let's just pretend this stuff never happened, because this was just like bad, and we don't want it to happen. So really, I'm just gonna vaporize that to happened, because this was just like anyway. So anyway, the restaurant, and it scars you for life. So anyway, let's just pretend this stuff never happened, because this was just like bad, and we don't want it to happen. So really, I'm just gonna vaporize that. It's gone, and we don't want it to happen. So really, I'm just gonna vaporize that. It's gone. Like, we're gonna pretend that never happened, and I mean that like really literally. Like, we're just gonna pretend it never happened ever. And then we're just gonna say that these are all gonna be back to the way they were, right? Like I said, it was just a mistake. I admit that, and we're like, don't harp on it, man. Right? I already said it was a mistake. Why you gotta keep bringing it up? You know, let's just move past it. We need to move past it. You know, don't let your whole life be defined by the one-time bad lunch you ate. You know. So anyway, let's go in here. Open debug block. Let's go in here. So anyway, let's go in here. Open debug block. Yes, that's gotta be this way. Again, this is just putting it back to the way that it was. Right? Debug push struct. Oops. Okay, so now in theory we're totally set now for what we wanted, except now oops. Okay, so now in theory we're totally set now for what we wanted, except for the one thing, which is the stored event situation. And so now we have to do is we have to just have a way of, again, doing what we wanted to do with the debug arena stuff. We wanted to do frames and the stored events. We wanted those to work so that as frames come in and stored events come in, we will free frames as necessary to make sure that we can store the new events that we get, right? And so essentially we just have two things. We've got new frame and we've got store event, and those two things both want to like get a new piece of memory, right? They want to get a new chunk. And so what happens here is we want to have some way of saying, if I can't get the memory that I need, free a frame so that I will be able to get the memory that I need. And so again, it's the same code that we wrote before. It's not part of the arena now. It doesn't need to talk to the arena at all. It just has to do something like, okay. And in fact, this stuff looks like it can be simplified now. That to-do looks like it can be fine. So let's see, that's just this, right? Yeah? We want to... Yes. Oops. Okay, so now in theory, we're totally set now for what we wanted, except for the one thing, which is the stored event situation. And so now we have to do... is we have to just have a way of, again, doing what we wanted to do with the debug arena stuff. We wanted to do frames and the stored events. We wanted those to work so that as frames come in and stored events come in, we will free frames as necessary to make sure that we can store the new events that we get, right? And so essentially we just have two things. We've got new frame and we've got store event, and those two things both want to like get a new piece of memory, right? They want to get a new chunk. And so what happens here is we want to have some way of saying, if I can't get the memory that I need, free a frame so that I will be able to get the memory that I need. And so again, it's the same code that we wrote before. It's not part of the arena now. It doesn't need to talk to the arena at all. It just has to do something like, okay, and in fact, this stuff looks like it can be simplified now. That to do looks like it can be fine. So let's see, it's just this, right? Yeah? So that's all good. Yeah, I think so. Although I would note that this should just be using our macros, right? This should use freelist deallocate or freelist allocate, right? I would think. Yeah. So like this should just be freelist allocate. Pretty sure. Although I guess neither of these things could really use that now because these are going to have to sort of do the recycling bit, right? Yeah. Okay. All right. So let's write this then. I'm going to get rid of this thing. And I'm going to say, okay, this is essentially what we have. I don't know that I need to zero struct here because we initialized everything, so I think this will just look like that, and we'll be good to go. Yeah. So what I need to do now is I need to be able to get these guys off of the free list, right? So if you remember, we have a source for these, right? We have a source. Not there. We have a source for these guys, which is like these. This is like our per frame storage management. So these guys are the two things that come in every frame. We get frame pointers, right? And then we get stored events that kind of, you know, accumulate. And so when we go to allocate either of these, obviously the first thing we're going to do is say, okay, just assume, first of all, that we can get it from the actual store there. And so then we have two cases. If we actually got it, then we just say that whatever the first free frame is going to be equal to the next one. Right? So we're popping something off the free list there. And off we go. But if we can't, and in fact I think this we might want to just say that this is effectively a while loop, right? This is essentially like while not result, we would say, okay, the debug state, we try to see if we can get the first free frame. If we can, then we're good to go. Otherwise, we will try to do a free frame. And in this case, again, the frame that we are freeing, we would need to, yeah, it looks like we don't actually really pop that off either. So we want to do free oldest frame. Either. So we want the frame. And in this case, again, the frame that we are freeing, we would need to, yeah, it looks like we don't actually really pop that off either. So we want to do free oldest frame. right? And so free oldest frame is pretty basic. All free oldest frame does is go, we have the oldest frame here. We say if there is such a thing as the oldest frame, then the oldest frame is going to be the one that gets freed. Frame. And we might say here that we might even assert this because in general, if we got into a situation where there was no more frames to free, we shouldn't be calling free oldest frame. I don't know. Well, I guess we don't really need to assert. I don't know. We'll see. So anyway, maybe we would say here, we'd say, assert that there is a frame to free or something like that. Anyway, we go free oldest frame. We say, okay, the oldest frame, if there is one, we grab it. We do a free frame of it. But first, we also advance the pointer forward. So we say, the debug oldest frame equals frame next. And if debug state most recent frame equals the frame we were on, the debug state most recent frame equals 0, right? So that's it. That's just all we would need to do to free the oldest frame. And so when we get a new frame, we're just going to do something like this, where we try to get it. If we can't, we free it, and we keep going, right? Store event will do exactly the same thing, like so. All that's going to happen here is it's going to be a stored event instead. And I guess I could change that to result. And so, again, the only difference here is instead of first free frame, it's first free stored event, right? And that's really all there is. Not really much else to it. So I think let's just compile that. Free frame doesn't take, that's true, it doesn't. And let's just take a look and make sure all the rest of our stuff is doing something relatively reasonable here. Free frame really much, and that's really all there is. Not really much else to it. So I think let's just compile that. Free frame doesn't take, that's true, it doesn't. And let's just take a look and make sure all the rest of our stuff is doing something relatively reasonable here. Okay. And the other thing I want to do is make sure that free frame does something reasonable. Yes, it does. Okay. So I think we're in good shape there. And so now we just need to kind of go through and do a little bit of cleanup here. Excuse me. And get everything sort of into a happy state. All right, so let's see where our bugs are first. I probably should step through this because we wrote a lot of code and we don't really know what it's doing. Or rather, we think we know what it's doing, but we don't actually know. But let's double check. So, okay. Oh, right. That code was a little short-sighted, now that I think about it. This part where it has to free a frame is actually only necessary if we're out of memory, right? So if we have some memory we could use, then we wouldn't actually need to do that. So what we want to do here is actually, this is the part that would do, do we have enough room to store this thing? And then if not, do it. Okay, so that would do essentially if arena has room for, then we allocate, otherwise we don't, right? And I don't like, I look at this and again, this looks like something that I would like to be able to abstract as well, which I probably could if I wanted to. I could probably make this an arena sort of thing that it can do. And I don't know if I should. Maybe I should, actually. I don't know, though. We'll find out. So anyway, inside this guy, where we've got the new frame and we do arena has room for, we're just saying like, okay, if we have room for another debug frame in the debug state, and this is going to be the per frame arena. If our arena has room for one of these things, then we will simply allocate it. Otherwise, we won't, right? And so that's, again, doing the exact same thing here. And so that basically says, well, however much memory we're going to set aside for storing per frame data and just letting it pile up, right? We will use up to that amount, and if we run out, we will then just start freeing stuff, right? And that'll be that. So pretty straightforward, right? And if I go down to where we actually set up our debug arena, which is somewhere in here. There it is, initialize arena. What I can do is do a sub-arena out of that guy for however much we want to handle, right? So we could just say, okay, we're going to do a sub-arena there, and the sub-arena for this guy. Sub-arena. The sub-arena for this guy is going to be our per frame arena. The arena that it comes from is going to be this one. The memory index of the size is going to be, I don't really know how much we want it to be. I guess we could say that there's a total memory size. And this would be some fraction of the total memory size. Probably 3/4 of it, or I don't even know how much we want to dedicate to it, right? Something like this. And that will just just allow it to sort of work in there. Now, that means that in addition to the debug arena, we do need a per frame arena in here. And off we go. So, arena has room for, I don't actually remember how we implemented that guy. I assume we just passed the size of, yes we do. Oops. Arena has room for, yeah, size in it. So that's just size of debug frame. Oops, size of. And debug stored event, same thing. Okay, and so let's see. Allocate rent, wait, what? Oh, I guess I didn't leave enough room. Allocate. Okay, and so let's see. Allocate rent, wait, what? Okay. Okay. And so let's see. Allocate rent, wait, what? Oh. I guess I didn't leave enough room. I don't actually remember, to be honest with you, how much room this thing actually has. 64. So yeah, so I guess we would need maybe to take maybe only half, let's say, and leave the rest. We probably should allocate a lot more debug memory than that, but, you know, we can change that. Change that later. All right. All right. So in theory, we are now actually, and theory. All right. So in theory, we are now actually, and you can notice our debug UI stuff is still working, which is kind of nice. So in theory, we are now storing all of our debug data. And we're storing it all based on the location that it came from. So now all we actually need to do is go through and start to actually use that now to sort of populate our hierarchical views. And then we should be back to roughly where we want to be, but without any of the limitations that we had before. In theory, at least that's the goal. Now, unfortunately, how much time we got left? That's not going to tell me. I guess we got 13 minutes. So I'm trying to think of exactly what part of this I want to start with. First of all, I would like to know why our frame... Let's just maybe do this. Why is our last frame time wrong? Right? That's weird. Wouldn't you say? Most recent frame, wall seconds elapsed. So where do we set the wall seconds elapsed? So it's every time we do a frame marker, it's whatever the value R32 is. So let's just see what's actually happening there. So in Handmade, debug interface, so we have frame marker, second elapsed in it. So it looks like that looks like it is correctly writing it down. So I'm wondering why we're never getting the right value there. Now, one thing that I haven't really thought through yet is when we're looking at the most recent frame, I'm not sure exactly when things get put on the most recent frame list. So let's see here. Frame marker, assert that there's a collation frame, put the stuff on there, finish the collation frame out, free the frame if we're paused, if we're not paused, put it on the list. So it seems to me like that should be working. So I'm going to go ahead and take a look and see why we're not getting that right. I'm going to go into that frame marker place, and I'm going to see what's going on there, right? So let's take a look. Frame marker. All right. So program is running, and now we've hit a frame marker. Let's take a look at what's going on here. So we've got our collation frame, the frame that's currently being worked on, which is right there. And it's wall seconds left on here. So, and now we've hit a frame marker. All right, so program is running. All right, so program is running, and now we've hit a frame marker. Let's take a look at what's going on here. So we've got our collation frame, the frame that's currently being worked on, which is right there. And its wall seconds elapsed are set to 0, which is exactly what we would expect. We're going to come through here and set our that looks like the right value. And then we add it to the list. So the most recent frame, wall seconds elapsed, is wrong. So this is wrong. This is totally wrong. That would explain it. That would explain it. So right here, this should also be setting the most recent frame, right? Wait, what did that say? Handmade debug.cpp changed on disk. Visual Studio, did you write my file? I know you did not write my file. You better not have written my file. Did you write my file? I hate the fact that this thing writes to files. I wish you could set it into a mode where it didn't touch your files, like debug only mode. Yes, I want to edit the buffer. Yes. Visual Studio. Hate Visual Studio. Urgh. Okay. So, what I want to do here is set the most recent frame as well. That was the part that was not actually happening the way it was supposed to. So now, in theory, oops, we should be back to having a supposed to. Most recent frame as well. That was the part that was not actually happening the way it was supposed to. So now, in theory, oops, we should be back to having a correct frame time. And hey, there it is. So that's what I would have expected. And that's nice. That means we're kind of good. So now, well, that was the part that was not actually happening the way it was supposed to. So now, in theory, oops, we should be back to having a correct frame time. And hey, there it is. So that's what I would have. Hey, there it is. Correct frame time. And hey, there it is. So that's what I would have expected. And that's nice. That means we're kind of getting our frames there. I also kind of am interested at this point in doing a little bit of statistics-y sort of a thing here. I would like to know, with our stored events, I'm kind of interested to know how many of them we have stored and what's going on there. So what I'm going to do is I'm going to go here and basically print out the size that's being used of that arena. So when we do last frame time, I want to do like a thing which also prints out. I'm interested at this point in doing a little bit of statistics-y sort of a thing here. I would like to know, with our stored events, I'm kind of interested to know how many of them we have stored and what's going on there. So what I'm going to do is I'm going to go here and basically print out the size that's being used of that arena. So when we do last frame time, I want to do like a thing which also prints out the per frame arena used. And this is just like how much bytes, you know, I just want to know like the basically the byte count, right? Of maybe like kilobytes, let's say, or something like that, that's getting used of that buffer. And so that's I don't actually remember if we put that in here, like get arena size remaining, I guess is the opposite of it. So we could just print that out. That's fine. I don't really care. So we could do get arena size remaining. And so I want to take that debug state per frame arena, and I want to. Why is the alignment? Oh, I get it. It's how much would be left if we assumed an alignment of 4. So we actually want to assume an alignment of 1. Just tell me the actual size. That's basically it. All right. Anyway, so we want to ask how much there is left in this per frame arena. Space remaining or something like that. I don't know. And then we want to print that out in kilobytes. So we're just going to divide by 1024 so that we have the thing in kilobytes. And that's it. Actually, that's all I actually wanted to print out. And so let's see what happens. Get arena size remaining. Cannot go arena 1 to memory remaining. That's a good point. I need to pass the address there. So let's see. Okay. So that's not really going to test what happens. Get arena size remaining. Cannot go arena 1 to memory remaining. That's a good point. I need to pass the address there. So let's see. Okay. So that's not really going to test our memory thing anytime soon. As you can see, we are going to take forever to run out of memory for our events, because right now we're not pushing enough events through it, which is, I guess, not particularly surprising, given the fact that we don't actually do anything except that one little test piece, I suppose. All right, so maybe that's not such a good idea. What I could do to sort of accelerate that process, obviously, is... all right, so... Alright, so maybe that's not such a good idea. What I could do to sort of accelerate that process, obviously, is when we do sub-arena and do this, I could instead, you know, just give it some laughably small thing, like, you know, maybe like 32K or 128K of memory, something like that. And so it would run out right away. At least that'd be the goal. And so that's what we want to have happen, right? That's exactly what we wanted. We want it to go down, and that, at least that'd be that. And so it would run out right away. At least that'd be the goal. And so that's what we want to have happen, right? That's exactly what we wanted. We want it to go down and hit 0, and now it's just like recycling. that memory. So assuming that things are working properly in there, that's exactly right, and we're happy. At least I'm happy. I'm going to go ahead and just step through that just to make sure that it's still working properly. Let's see here. Looks like that's the case. Let's see if we ever hit this case. We do. Yeah. Let's see that, and we're happy. At least I'm happy. I'm going to go ahead and just step through that. I'm happy. I'm going to go ahead. Happy. At least I'm happy. I'm going to go ahead and just step through that just to make sure that it's still working properly. Let's see here. Looks like that's the case. Let's see if we ever hit this case. We do. Yeah. So I mean, we haven't really checked it very thoroughly, but it does look like it's working the way we expect it to work. And we could do something like this. Okay, so I think we've got ourselves in good shape now. So I think I'm going to call it there. And then the next thing, because the next thing we want to do is to then go like re-enable the UI stuff and start playing around with the fact that now we have this sort of centralized stuff. So I kind of want to start smushing those things back together. So that's pretty good. And I think that's... yeah, I think that's a good stopping point. I don't think we want to do anything else there. All right. So I think that's a pretty... one of the things I say a lot of times when we talk about programming is it's just like, you don't want to eat more lunch than you can reasonably digest, right? So, a lot of times people go into something and their eyes are too big for their stomach and they'll just way overeat the lunch. And so what I'm trying to do here is just keep lunch to a reasonable amount of food. So that we don't get too fat, but we do get enough food to keep ourselves going good. And so then there's always, again, like I always say, there's always lunch tomorrow. And so that's, tomorrow's lunch will be, will be just as tasty as today's lunch. And, we can eat some of those other foods that we didn't eat today at that time. So with that, I'd like to go ahead and go to the Q&A. Oops, if I type it correctly. So if anyone has any questions about where we're at, please prefix them with Q:, and ask me, and I will answer them. Miblo, when we come to do the AI system, do you think it'd be reasonable to give the dudes a gather lunch behavior? Well, if there's lunch, I don't know that the game has much lunch concepts in it, but, we could try. Insofar as, what did you have for lunch? I had campfire barbecue for lunch, which is the best barbecue in Seattle. It's very, very good. It's only available on Thursdays and Fridays. Or if you live in Georgetown on Saturdays, but I don't. So it's only on Thursdays and Fridays, and it's a fantastic, fantastic barbecue. Anyone who's in Seattle is doing themselves a disservice if they do not go to Campfire Barbecue on Thursdays and Fridays. So you should do that. Doritos Ranger, imagine that you're young again and you're eating your lunch, and you can choose between a C and Java-like language in what you can work with memory in much C-like way, but that language would say how to implement some ideas, like a Python is about line offsets, which is not good, I think. What would you choose then, and why? I so don't understand that question at all. Basically, I think C is a perfectly fine language right up until the part where you try to do more higher level organization and generation of code. And so C, I think, is good, and I don't have a lot of complaints with C. There's some minor things I would tweak, but it's pretty good. Java is just garbage. I have no use for it whatsoever. So I would say I pretty much always would pick C, and then I would want, basically to add like the new features to it that I would want. But Java definitely, I don't feel like Java has any redeeming social value whatsoever. I don't think Java has a reason for existing. It is a not useful thing. During HMH Con, will there be an organized lunch at the Campfire Barbecue? No, because Handmade Con is on Saturday, and you cannot get Campfire Barbecue downtown on Saturday. As far as I know, anyway. They're usually in Georgetown, and that's very difficult to get to. Does Emacs offer more syntax support than what I am seeing at the moment? Do you mean syntax highlighting support? And if you mean syntax highlighting support, the answer is yes. There's a lot of weird syntax highlighting support in there, but I don't use a lot of it. Let's see. Any other questions about the code? Is there anything that could be considered a free lunch in low-level optimization? Sure, when Intel comes out with like a new chip that happens to run your code faster and you didn't actually do anything. That's definitely a free lunch. Cuber Caleb, fair warning, the optimizer might store the strings in the same place, which will break the whole GUID thing. No, it can't. There's no way for it to store two strings in the same place if they're different, right? So unless you're thinking of something I'm not thinking of, that's not actually possible. BTN games, do you suggest programming should be snacked upon throughout the day as an alternative to a 3-course code feast? In general, I would say that you want to do at least 2 blocks of 2 hours worth of coding every day at a bare minimum. And preferably 3. And I mean actual coding. Like not Facebook is open, not I'm code reviewing something. I'm only talking about like making code in the computer. You should be spending, preferably 3 2-hour blocks. And then, yeah, you're not probably going to get 8 hours of programming every day because realistically, you got a lot of other stuff to do. In the course of actually making a game, there's lots of things to do. I know I oftentimes, nowadays, actually, some days I don't get any time to program because I have tons of other stuff I have to do. I have to do 3D blockouts, I have to do lots of things. So I have to manage my time blocks. And some days I get to do programming, some days I don't, and that sort of thing. But yeah, assuming that your job is programming and you're not having to substitute and make art or do other things with it, then you should be doing hopefully 3 2-hour blocks a day of solid coding. If you can get 4, awesome. I these days tend to get 3 plus the 1 from Handmade Hero, so I do tend to do roughly 4 2-hour blocks of things. And I sometimes get 5 because I'll get another hour or 2 block of maybe I got to work on stuff at night like The Witness or whatever. But never let yourself go below 2. If you go below 2, something's wrong. Insofar as, why do you think there have been no good new languages since C? Are all the language designers out to lunch these days? Yes, they are. The reason that I think is because C was like the last time where great programmers made a language. And as far as I know, pretty much every language that was made since then was made by people who actually aren't great production, commercial code shipping programmers. I mean, the people who made C made Unix, right? They knew what they were doing, and they knew how to ship actual actual software, and I think that that's part of it. It's one of the reasons I'm so excited about JAI is because JAI, like what Jonathan Blow's language is, it's the first time a programmer who actually really knows what they're doing is making a language and has shipped multiple very complicated, very advanced things by themselves in some cases, right? I just don't know very many other times when that's ever happened. And so I think that tends to be one of the big reasons that there are so many languages nowadays, but most of them just really aren't very good at actually achieving high quality software, is just because the people who made them weren't experts in making high quality software. They were either academic or they were, trying to make, low quality software quickly or things like that. And so the goals or the knowledge were not there, one or the other. Bookie's Revenge, do you feel there's a perfect balance between test-based coding, so more efficiency optimization, or do you prefer one over the other? I'm not sure I understand the question. I feel like test-based coding is a totally reasonable thing to do as long as you're not spending more time total in development. I've said this many times. Basically, development should be looked at as a sort of global optimization problem. What you're trying to do is you're trying to take the least amount of time to make the best possible code, right, for the thing you're doing. And so if test-based code, if test-driven development is actually if the amount of time it takes to make the tests is less than the amount of time it would take you to debug problems later on that the tests would have caught, then it's a good trade-off. If not, then you're just wasting your time, right? And like a lot of people are dogmatic about those sorts of things, but don't be, right? There's only one thing that is actually true, and that is what made the best code in the shortest possible time. Like that's what you actually wanted. And so only do something like test-driven development or whatever to the extent that it actually leads to the same quality product in less time. If it's not doing that, then it's a waste of time, and it's hurting your development process. And so I don't think there's anything as like you're asking a perfect balance or whatever. It's more just like you need to know these things. You need to learn enough and get used to the way you program enough to know when it's appropriate to do test-based, because you know the thing that you're working on is difficult to get right. You know that if you spend time to make the test now, you'll save a lot of time debugging later, and you'll ship a less buggy product. You should know those things, and you furthermore should know the kinds of bugs you make, so that your test-driven development might not be the same as someone else's, because the kinds of tests you might need to make are different than the kinds of tests I might need to make, because maybe I don't ever make a mistake of kind X, but I do make kind Y, and you are the opposite. You never make mistake Y, but you always make mistake X. Well, our tests should be geared towards that. My test should test for the kinds of mistakes I make, right? Et cetera, et cetera. What are your thoughts on Clang? Trying to build it in the source tree, like the source code is a mess. It's a nightmare. It's way too object-oriented, and it's just like, it takes thousands of lines of code in Clang to do something that you should be able to do in one line of code or something, right? So I don't like that aspect of it. But in terms of the actual quality of the product relative to, say, Visual Studio's compiler, it's actually quite good. So I think they did a nice job. I feel like the coding practices in Clang make it a very hard source tree to work with, and probably a lot less efficient and probably a lot less easy to modify than it should be. But even that said, compared to the competition, it's quite good. The Maxis, I think he meant string literals like the OG flag, I think. Not sure what that refers to. What do you think about Unity, etc.? I don't have much of a thought about Unity. Any licensable tool, you can really always evaluate it the same way. Does it do what you need it to do? And if so, then you could use it. If not, then you can't. I think the biggest problem that I see, or the thing that I think the mistake a lot of people make, is they don't really account for all of the problems with something like Unity or Unreal Engine or whatever. And so, I think people don't really appreciate what actually goes into making a quality game, even with Unity. Because a lot of times people will use Unity, but then the thing that they ship is like really low quality, right? And so just using a licensable engine doesn't give you a high quality thing. You still have to do a tremendous amount of work to make a high quality thing. Engines aren't at the point where you can just like magically just be a designer and not have to know anything about programming and expect it to come out good. The only time that really works is if you're making something like exactly like what the engine's demo does or something, right? Like if you happen to be making Gears of War, you probably can just use the Unreal Engine, right? Or something like this. But so I don't have much thoughts about those sort of things. Personally, I have a very low tolerance for a lot of the design decisions in a lot of those things. They aren't designed the way I would design them, and they don't work the way I want them to work. So I tend to not like to use most of that stuff. I also don't like to be beholden to somebody else for my core technology, and that's just, part of building a company and so on. So I have plenty of extra reasons why I wouldn't use something like Unity, but that's